Peeps, it's Julian here from Tutoring, and as always, it's such a pleasure to join you. We're on to 4.2 from the 2017 Maths Lit Paper 2, and this question deals with reading data from a table and also with broken line graphs. Okay, so they said table 6 on Annexure F shows the total number of storms from 2010 to 2015 that affected the 4 world oceanic regions, as well as the cost of damages in millions of US dollars during this period. So if we go have a look at this table they're referring to, you can see here that they've given us the world oceanic region. So we have the Indian Ocean, the West Pacific, the Eastern Pacific, and the North Atlantic. And this table for each year shows how many storms there were for that year. So like in 2015, in the Western Pacific, there were 39 storms. And then it goes on to also give us the cost in US dollars, that in millions of US dollars, that year cost. So basically in 2015, it was 258 million US dollars caused in damages in the Indian Ocean. So using this data, and they've given us a line graph over here with a plot of the number of storms. So they've used this table over here to plot the storms for the Indian, the Eastern Pacific, and the North Atlantic. So going back to the questions now, they're asking in 4.2.1, determine the missing value of n. So you can see n is over here and over here. So it's basically we're going to need to use this line graph to determine what this value n is. So if we go to 2013, we go on this graph and it's the Indian Ocean we're looking at. So the Indian is this line graph over here. In 2013, we've got that this data point here corresponds to 10. So there were 10 storms for this data point over here. And you can see in 2011, which is the other n, it's the same value of 10. So if we go to our answer sheets, we then write down, so for question 4.2.1, n is equal to 10. Okay, then 4.2.2 now asks us to draw another broken line on the answer sheet representing the total number of storms affecting the West Pacific region from 2010 to 2015. So I'm just going to do this on the answer sheet. So I'll write here on answer sheet. So you'll be provided with this graph to do the answer on. So if we go have a look now on the answer sheet, they are asking us to, so the missing data is the Western Pacific. So let's double check there. So yes, they're asking us to write the Western Pacific region number of storms onto this graph. So you can see how here are the data points. So we can plot this on the graph. So I'll choose a color of, say, green. So basically in 2010, it's 19 storms that happened. So you can read off here, you can see in 2010, it's 19 storms. So if we go to our graph, we can plot that in 2010. If we look on this, if we look at the scale, so each line here, you can see starts from 0, but there's 1, 2, 3, 4, 5. So to get up to 10, that means that each one of these must represent 2. So this would be 2 storms, 4 storms, 6 storms, 8 storms, 10 storms. So when we're plotting now, we need to plot 19. So 19 will be halfway between 18 and 20. So the point will be around here. Okay. Then for the next year, 2011, we're looking at 40. So if we go up to 40 and 2011, we need to plot a point. So in 2011 and 40, we have a data point over there. And then now we look at 2012, so there's 34. So in 2012, we see that it's 30. The first line above 30 is 32, and then the second line is 34, so 24 will be over there. Then the 2013 says that there were 52 storms that year. So if we go up on this graph, it is the first line above the 50 marker. So for 2015, it's over there. For 2014, it's back down to 30. So we plot the point over here. So we can see that the point is there because over here is 30 and it's on the year 2014. And then finally, 2015 says there are 39. So 2015, so it's just one before 40. So it's the halfway point in between 38 and 40, which is over there. And now because this is a broken line graph, we need to join this together. Use a ruler if possible. I don't have a ruler because it's on the computer, but the line should look, just join every point as best as you can. Try and be as neat as possible. And you just put the line through every point. So that's what the line graph should look like for question 4.2.2. Okay, then going back, they have now asked us to, in question 4.2.3, name the region that showed a downward trend in the number of storms experienced from 2010 to 2014. So looking at this graph, we can see 2010 to 2014. So basically this graph is working in a sort of reverse. So the time is increasing as we go from right to left, which could be a bit confusing. But basically, if you look from 2010, which is this line over here, we need to find the line that is downward trending. And clearly this one goes from a reading of about 21 all the way down to below 10. So there'll be 9 there. So it's downward trending. And if you look at the key, this line refers to the North Atlantic. So the answer for 4.2.3 is the North Atlantic Ocean. So North Atlantic. And you would get 2 marks for this question. Okay, and then finally on to 4.2.4. They are asking us here, so they've said that a news reporter compared the total cost of damage caused in the Western Pacific and the North Atlantic regions to the total number of storms from 2011 to 2015. He stated that the more storms a region experienced, the greater the amount of damage was caused by them. Verify showing all calculations and give a reason whether his statement is valid. So if we go look at the data, they're talking about, so he wants the Western Pacific area, which is this data over here. compared to the North Atlantic area. So it's this data over here. So first of all, we need to find out what were the total amount of storms from a period of 2011 to 2015 for both these regions. So if we go and start off by calculating the total amount of storms for the Western Pacific, so the West Pacific, okay, so the total storms equals, so we need to now add 39 plus 30 plus 52 plus 34 plus 40. We don't add the 19 because the question just said from 2011 to 2015. So we need to add those together. So as I said, the total storms is 39 plus 30 plus 52 plus 34 plus 40. Put this in your calculator and you get that the total number of storms is equal to 195. We also want to calculate the total cost for the Western Pacific area. So the total cost will equal, so again, as I said, we're looking now at the Western Pacific area, and it's from 2011 to 2015. So we need to add the 10,600 plus the 6,080, 22,800, 8,410, and the 10,200. We need to add all of these together to get the total cost, and this is in millions of US dollars. So as I said, going back to our answer sheet, we need to find that sum. So it was 10,200 plus was 8,410 plus 22,800. Let's go on the next line here. So plus 6,080, and finally plus 10,600. So those five numbers, again, I'll show you, it's from that table over here. So you put all of those into your calculator and you get the total equaling 58,090 US dollars, and it's in the millions. Okay, so let me write that meter. So US dollars, and it's millions of dollars. So 58,090 million US dollars. So that was the total cost. Total amount of storms is 195. Now we're going to do the same thing for the North Atlantic. So we need to get the sum. So the North Atlantic region, we have the total storms. Okay, we go back, is a sum of those five values. So it's 12 plus 9 plus 13 plus 19 plus 19, not adding 21 because it's not in our range of dates that they've asked for. So as I said, total storms is going to be 12 plus 9 plus 13 plus 19 plus 19, and this equals 72. that in your calculator. So we've got the total amount of storms is 72. The total cost, so your total cost is now going to equal, looking back at our data, we've got the total cost, which would be 21,000, 75,000, 1,510, 232, and 590. So on our answer sheet, so as I said, it's this 590 plus 232 plus 1,510 plus 75,000, and then finally on the next line plus 21,000, and this all comes to a total of 98,332, and it's in US dollars. This is the sign for dollars, and it's millions. So as we can see by this data that the Western Pacific had more storms, but its total cost was actually less than the total cost of the North Atlantic, which had less storms. So the statement made by the reporter is incorrect. So therefore, statement is not valid, and the reason, because I asked for a reason, is Western Pacific had more storms but cost less than North Atlantic damages. Cool. So Western Pacific had more storms but cost less than the North Atlantic damages. So we just verified that this reporter's statement was incorrect. And that's a wrap for 4.2. Before I go, I'd just like to give a special thank you to our epic sponsor for making this video possible. Read all about them in the description below. Be sure to visit our website for more of these epic tutorials. And remember, if you can't find your answer to your question, you can send us your question and we'll respond with a personalized video just for you. And until next time, stay epic.